right. So in this video, we're going to quickly go over a few things here. One is how to decide which motor is going to be good for your frame. And there's quite a few motors available out there. So let's go find... Put together a list in a 3D environment here for y'all that gives you... Make sure I'm streaming. Yeah, okay, cool. Audio good, check. Yeah, that'll be fine. When it comes down to picking your motor, you want as small as possible, as light as possible, and the most amount of power. The trifecta, you can only have 2 of the 3. There's technically 5, 6, 7, 8, 9. You can still only have, can't have all your cookies and cake and eat it too, or whatever it is. All right, so let's start off with the tried and true, the most popular motor out there. That is the QS138. It is known under the QS website as the 138A. It's really confusing. People call it the V3 or the QS138 V370H. What you call it, I don't really care, but we'll find it here for you, and this is the motor. So we're all used to this motor right here. This is going in damn near every electric motorcycle over the past 5 years. I can push 30 kilowatts for just a few seconds until it doesn't need to accelerate anymore, then it sticks at 20. Technically, if you overgeared it and went up a really steep hill, sure. At a motocross track, this thing works good, feels like a 125, falls on its face after 35 miles an hour. That's fine, but the problem is it gets really hot. It is air cooled. It's about 12 kilograms. Do the conversion for that, 20-something pounds. So I'm going to give you a comparison now to a newer motor, the QS165. I'm going to overlay that here. As you see, it's a little bit smaller. Well, not a little, a lot. So 138, 165. Let's look at that from above. 138, 165. Darn near the same. The 165 is a little bit larger in diameter here. However, you can find ways to creatively bring it down closer to the frame in some cases. At the end of the day, this 165 can do 40 kilowatts versus 30. It's rated for 12 versus being rated for 5. The weight, you add a few more pounds, there's more copper in there, more laminations on the stator. They also went with a larger diameter 20 millimeter shaft. This spacer right here, well, I can't move it up and down because this is one solid file. This spacer can be moved up or down. The sprocket can come up a little bit or down a little bit. It's up to you if you want to screw around with that. It's a standard spline sprocket. You can buy it from them in a 428 or a 520 pitch. It's up to you. You can buy a Yamaha one on Amazon. There's other people that sell them. So here's the specs for that. I won't bore you with all the specs. We mainly just want to see the size here. So next I'm going to go in and talk about why, I'm not quite sure why no one is using this designation model here. The H, I kind of like this one. It's been out for a while. Russia market seems to really like it. USA market, for whatever reason, chose this one. Same specs. This is the same exact motor on the inside, same gear ratio, same spline, different mounting patterns, and different phase wire outputs. So interesting motor. I wish more people were using it. So I'd love to see some people build with this. Maybe because it doesn't have a mount up here to the front, that you had to find a way to use it in the back. Perhaps that's why. But all right, let's go with the next. So I'm going to consistently keep the tried and true most popular one out here from a top view. Actually, let's go to how it's mounted in a frame. So typically this is how you'll see it mounted in a frame. It's a bad photo. I'll get you a better photo shortly. But it goes through the swing arm bolt right here to right there. You'll have to use spacers. KTM is 17, I believe Yamaha is 18. Then the front, you have to figure out a way to screw down. Sometimes you have to drill out the stainless steel. This is Lithium King. He makes these for everything, all the popular ones. Let's find his version for the 165. Hello? There she is. So, I'm not sure. Maybe I didn't add the image, so let's add it right now. 165 mount. Here we go. 222. So, same thing. I don't think Lithium King likes giving big photos because they don't want people to steal their intellectual property and make renderings and cut their own. But same thing, swing arm bolt goes through here and you figure out how to mount the front. All right, on to the next. So 138, goodbye. Oh my goodness, come on. There we go. So 138, now let's overlay the new motors from 3 These things are absolutely blistering, crazy, way more powerful and heavier, tiny bit larger. So let's start with their 65. This is gonna whoop this one all day long. In fact, a little bit shorter, not by much, but shorter. And then they have their larger 80. So let's show this one right here. So the 65 and the 80 are identical gearboxes, identical lamination sizes. There's just more laminations making it taller. So let's get rid of all that. I'm going to show you just the difference between them both. Let's get a side view, perfect. So 65, 80, 65, 80. You see that extra little area between here and here? That is your extra length of laminations. More laminations mean more copper, more exciting power, and that's why they're able to give you some pretty insane specs on what they're able to do. Rated power 30 kilowatts, peak power 81. Who's doing 100 horsepower? Not me. I don't have a battery that big, but if you want to, cool. This would be a little more 450 power right here. 25 kilowatt, that's rated. That means it's good for a consistent 25 kilowatt, assuming you have cooling. 50 kilowatt, well over 60 horsepower, 70 horsepower, no problem. They have their countershaft sprocket a little bit closer, which means you can push your motor closer to the frame. I like that, that's good. They don't have a bunch of weird mounting bungs sticking out in this area that get in the way of your frame and your swing arm pivot right here. You can still grind off a little bit if you want, if it gets in the way. Let me get rid of this sprocket real quick. So, great little motors, caveat. They weigh a little bit more, 14 kilograms. Not much more, but a little bit more. But for that weight, you're getting damn near double the horsepower or watts. So really good motor. These just came out this past quarter, 2026. 3 collaboration with a well-known electric motor company designer, in-house with them. So they're doing really good stuff. All right, let's clear those out. Go back to our baseline. Let me... All right, back to baseline, and for the fun of it, let's go to the 120 motor. This is what's on KTM 65 conversions, a lot of people use them. Huge difference in size. This little guy is not rated for all that much, but it's just fun to see. However, look what they just made, a 128. So the 128 is the same gearbox style. However, the gear ratio changes significantly. Why they did that is kind of confusing to me. So these specs he just released to me, he said they're fine to show you to all. Look at that gear ratio, 3.4 versus the standard 2.3 style. So where's our gear ratio on this? I don't know if they list the gear ratio on this, but the RPM for this is basically the same as all the other QS motors. So we can just pick this one, which is 236. So the QS120, let's just pretend it has whatever gear ratio it does. The 128, this thing's going to be a little powerhouse. This is a hairpin motor. Hairpin meaning it's got the goods to do. Where's hairpin? Here we go. So this is a hairpin motor. This is the 155 from the XE Pro R and S. So when I was here at the QS booth, they did not have the newer motor. They did have the 165, and that should be here or something. But anyways, this thing's a hairpin. This thing is max 10 kilowatt, which means we'll probably be able to push 20 kilowatt. Super cool little motor. I'm actually going to try to put one of these in a full-size motocross bike. It's going to allow me to have some more room for the battery. Maybe it'll just be more of a trail bike. I'll see how it does on heat, limit it to 20 kilowatts and see what happens. So let's go back to baseline. 138 versus, let's do we already did the 165. Let's do the 90. So it's kind of interesting to see it side by side. So that's how much longer this can is. The 90H versus 70H here. You can look at it from top, 90H versus 70H. Width doesn't change. Well, it's a 138. All right, so that is everything. You guys reach out and ask, let me know if you need to see anything else here. I'm gonna give you a frame real quick so we can play around with that. So as far as mounting, what you want is to get this as close as possible, this countershaft as close as possible to the swing arm pivot, not being motor being too low or being too high, because that messes with your anti-squat. Typically what you should do is just prior to taking out your gas motor, make a template from here to here to here with some clear plexiglass or a piece of plywood, and just have a drywall screw going exactly where your original gas motor countershaft sprocket was. There's many other ways to do it. I use string or tape or whatever you want, or an old photo with some measurements. Let me open an actual model with my frame scan. This is a 2023 frame. It's a 450. And I got two motors loaded in here. Well, while those are loading. All right, questions? Hey guys, so let's see. Yeah, Ray, the GBX65 is, just get it. I'm gonna start printing these out and shipping them for 40 bucks for people. It's a 10-hour print $4 worth of filament, but the $40 is just because it's wear on my machine and whatever. But anyone can, I'll get the STL for y'all. All right, random trying to ask about a 3-shoal. As far as which 3-shoal CL700 you have, find me on Facebook, ask me in a DM. There's so many different ones, so sorry about that. Cool. So 3-shoal GBX65, Okay, cool. This is loaded. So 2023 frame. So this is with a 165 60H. These are some motor mounts I'm making here. You see in purple. The idea here is to just utilize the original frame members and tabs. So it's just literally direct bolt. This will be a 17 millimeter swing arm bolt, goes right through. This is a 12, this is a 12, I think, maybe a 10. Doesn't really matter. What's important is if you put your motor too low, then your chain will drag on the bottom of your swing arm. And that actually also affects, let's see if I have an anti-squat page still open. That also affects a lot of things like anti-squat. I'll put this link in the description. So anti-squat, what you don't want is while giving power for your rear tire to lift up. On an off-road bike, if your countershaft sprocket's in the wrong place, you will put a lot of unnecessary load on your suspension. It's going to do some weird stuff, so it's going to drive. It's almost like if you've ever been late diving into braking bumps. Well, imagine you're just giving throttle and your shock is just bouncing up when it doesn't need to, or it's doing it more than it needs to. So just follow what you originally had. Your motorcycle manufacturer has been working on this hard for decades, so don't fix a good thing. However, sometimes we can't fit these damn motors where we want to, so we have to deal with moving them around in different areas. Oops. Oh, come on, you little shit. Great. What we have to deal with is the motors being in a weird area where we can't sometimes get it to where we want to go because this stupid bung is rubbing on this stupid thing. So in my model here, I have this motor way too close to the 17 millimeter shaft here because the swing arm actually comes out here. You got your needle bearings and all that. So this motor is technically too close. I do need to move it more this way. It's much too close. And that's my fault. I didn't 3D model a swing arm. So with that being said, these are motor mounts. I'm going to get these machined out of CNC, aluminum, 6061. I've already done a mock-up. They work fine. This is just a bad 3D environment. Next thing, most people do cut these off and cut portion of this off to fit a larger battery. We always want the biggest battery, but what we don't want is for it to stick out and rub on our knees. No one wants that. If you're an aggressive rider, that is the last thing you want. So generally speaking, you can fit 2 batteries wide here. This is about a 20 series 12P pack max you can fit in here, or a 26 series 9P pack. That's using a pretty complex shape like this, which adds to the cost of the battery. You can just put a simple square in here and whatever you need. So what I wanted to show you on this is what happens if we put, say, a different motor in here. Let me get rid of this motor and we'll try the, just because I was curious, I really was hoping and really want this motor to be something that's amazing. I would be really excited if this thing ends up being something that can do 22 kilowatts. Will it? I don't know. Hairpin doing 20 kilowatts when it's only rated for 5, probably gonna not be as resistant to heat as the others. But look at all the space we gain by the smaller motor. I can chop this thing off here, can't chop it off here. I'll have to do some different thing. But I could chop this off here. Now I get, look at the difference in more batteries. That's a whole row of batteries I could fit right here. 1, 2, 3, 4, 5, 6, 7. And I want to fill up this area here with more batteries. Imagine all the batteries I get now. I get to go down here. I get to go down here. I get to go down here. I get to go over here and so forth. So all this extra space right here, this is an extra 7 miles of riding. So this is why space matters. Plus this motor is 10 pounds lighter. So we get 10 pounds here, maybe we end up making a smaller pack, like just a simple, cheap battery pack from one of the motor manufacturers. You can make an electric kit, cheap motor, cheap battery pack, smaller controller, ends up being 25 pounds lighter for a bike. You just have 2 of these battery packs, or maybe even if you have a Surround Light B motor sitting around. The problem with this motor though is, however, is the RPM. The gear ratio is just boo-boo. So you'll have to run 26 series, stuff like that. All right, any other questions? So, pouch batteries, sure. They're just nothing I ever want to build. I use cylindrical batteries, that's all. How are you going to attach the motor mount? Or I'll show you right here. It already is taken care of. This swing arm, those are spacers right there. So literally the swing arm bolt goes through here. That's 17 millimeters. I hope that makes sense. Say 17.1. So I gave it a little bit of tolerance. It could be 17.35 or something. Doesn't make a difference. I could make it 19 or 10. So I hope that answers that. So it's just going to be clamped in there. This frame can move 2 millimeters in when you torque it down, and that will sandwich. These are spacers. Sorry, this is a swing arm. These are the swing arm spacers that the needle bearings go around. So when the big 17 millimeter bolt goes in there, torques down, boom, that's held in. That's held in very strong, squeezing, and then this squeezes against the motor as well. All right, any other questions? Yeah, I'm not doing any weird 90-degree underneath swing arm, but yeah, sure, go for it. But you have a linkage on a lot of these bikes. All right, so let's go over, I guess we can go over some controllers. So we have Fardriver. These are cheap, like really, really cheap. Alibaba. ND 72680. All right, controller like this, just to say it's $200 something shipped to your door. You can go to Econic Cycles and get theirs within just a few days. They are a really good company. They charge retail. Can't hate them on that. They're very transparent and very open. So let's see, 72680. All right, so see if they charge an extra $75. Big whoop. All right, so this little controller here is perfect for damn near any of the motors we listed here. The thing is, it's only going to do 20 kilowatts or so. So if you look at the specs, I don't even know if they have the specs. Max line amperage, 350. So at 72 volts, 72, which is about 84, but under load, it's going to be about 79 at full throttle, times 280. You're getting 2,200 watts, 22,000 watts. And that's basically how you do it. For example, Suron, when they're rating their controllers, Suron, oops. So this controller on the back, there'll be a part number and it will say something, 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 dot 230 or 180. So like a 230 would be the year 2025. So it's 230 amps times, let's just say 79 volts. They might measure it by 81, plus they have their turbo. So that's generally how you get these ratings. So when you want to start pushing more power, you need more current from line amps. And that's where these larger controllers come into play. So the ND 96 1000. And this gets you quite a bit more line amps. So what are we looking at here? 450. So let's just do 79 times 450. Jesus. So that's 35,000 watts. That's a lot. 35,000 watts divided by 750 to get you horsepower. It's 46 horsepower. That is a good amount of horsepower. This has 450 power. Darn near, you need 1200 to get true 450 power or Stark 60. That's fine. Let's go 3-spool. So 3-spool kind of made a audible mid through last year. They moved away from the actual VESC platform, kind of like how EBMX did. Everyone knows the EBMX. They originally started as VESC, but they also did that audible. They were in the Discord VESCs and the VESC discussion forums asking how to build this thing and trying to, in the very beginning. And then once they had a product, they kind of moved away from VESC. That's my full memory and understanding of it. Don't quote me or yell at me, but let's pretend this is a VESC inside, all good. They're able to get their peak power by running quite a bit of battery amps. This thing does what, 500, 600 battery amps. So let's move back to here. Same idea here. So you now have the Ferox and Leo from them. So same controller, same display, all that good stuff. It's just the MOSFETs inside they change, and a little bit of the logic and programming and such. They need different equipment to control the gate drivers for those MOSFETs. The buck boost converter, the 12 volt DC converter in there should be the same. I think he builds it the same. So this is VESC, but better. Basically, you guys can't screw it up, and you can just press auto learn and shoot a configuration in there. VESCs were so hard for everyone. I still prefer them. It's all good. Here's the Leo. These are when you're running much larger voltage. So are they good for 126 volt max? That's really it. Should you be running 30 series full throttle while landing off a jump on a motocross track on a Leo? I suggest not. Does he say you can run 30 series in one of these? He does. So cool. All right. Okay, good. No other questions on that. All right. So might as well, since I'm blabbing on. So as far as where you mount these controllers, I've gone from putting them up in the airbox to mounting them exactly where the front shroud is. You get a constant airflow. They're already waterproof. The motor cables are just as routable, and these will fit right up there. You got to make a little bracket. You can also stick them in the airbox. Really, truly up to you. And then let's find one other controller for you. We have the Electro and Co kit. What do you got? So they use an EM260 on most of their stuff, and that's the Votol EM260. Now you can buy this anywhere you want. These are a little more robust. Their software sucks, like literally sucks. One of the hardest things to learn, even if you have a Bluetooth module, good luck finding an app that works with it. You got to use a WeChat mini program. If you don't know what WeChat or mini program is, good, don't. So they sell a kit. Where did it go? That was weird. Electro. So they sell a kit, they mark it up, they have their own custom bin file, firmware file in here, so they technically boost these up a little bit more. These run hot and will do fine hot, a lot hotter than VESCs. They're potted fully inside, waterproof, pretty bulletproof. Throttle control is decent, not too configurable. You get 3 mode switches, low, medium, high. That's it, but they work. They just work. And if you want a display, you use a little voltmeter. If you want a different type of display, you can use a standard electric, like many of these displays will work. So I think that covers it all. If you guys have any more questions, where are y'all? You guys have any questions? Do some open questions. Let's go for it. Let me get rid of the screen share here. All right. If you guys don't have any more questions, I'm going to go poop or something. Let's see. What are pub parts? Explain. When will someone make library parts? Do you mean like when will someone put them up on GrabCAD or like make them open source? And when you say flash no limits, what does no limits mean to you? I've heard no limits, but that's an analogy used somewhere else. Flipski garbage. Sure. What does Flipski have? I'm scared to go look. I mean, they're great for 120 motor, sure. Do they have like a really big one now? That's new news to me. All right, I'll go back to live screen on that. All right, let's see what Flipski's got. I'm nervous. All right, ESC, VESC. 20, Jesus, what is this one? Oh my God, what is this? All right, you got me. I have no idea. It's Flipski. I'm still nervous, but that looks pretty cool. I'm not willing to test it out. $360. That looks okay. What is that? 6-gauge wire? Can't tell based off these M5s. Wire bungs. I mean, peak current, 1,000, Jesus. All right. Now, they generally and always go off of phase current. So their peak continuous current is 400 amp phase. So that's usually like 200 battery amps. This would be probably 350 battery amps. Not terrible. I'd say this is equivalent to a CL1000, but I doubt it. But cool. I don't know. Someone try it out. Where are you? When you say JWANVB, when you say no limit, yeah, you can, as long as every VESC manufacturer is supposed to supply their source code. That's part of the agreement with using all the hard work done by everyone prior to them. You're walking on the footsteps of your founding fathers there. Thrucial, very naughty. They don't ever fucking, I can't use that word. They don't ever give their full source code. You can ask for it, but it means you can't simply go in there and change stuff. But if the source code's available, you can absolutely change that. Soak it in mineral oil and run the amps more, sure, but you're eventually going to find the limit of those MOSFETs or the MOSFET bank. So I would say no, don't do that. But yeah, Quinn, as far as the library, like I put a lot of work into making these. Like if I just open source this, and then spend all the time frame scanning, what's the point? I mean, I'm doing this to support, not gonna make a living off of this. But yeah, you're not gonna find many people putting this stuff out there totally free. That just doesn't make sense. That's why Quasar, which is Manny, sells his kits. It's plug and play, very expensive. Quasar electric, can't spell. I mean, you want to see how much he charges? Let's see. All right, 85 kit, $4,000. That gets you a battery. Oh wait, gets you a battery. So this battery costs, I don't know, 800 from them. This motor costs 200. That's 1,000. Noisy Cricket. That's 300 something, 400. So this is like $1,400 bill of materials. This is a $4 switch, and yet charging that. I mean, yes, there's looks like CNC desktop Shipoko or something, CNC router based off of the marks of there. Maybe he's got a nicer mill, or I don't know how he's doing it. Not, but I mean, this is a lot of like Lego assembly and a lot of parts. This costs a lot of money to build, but it is truly plug and play, and it is a whole cradle frame. So that's a lot of money. So is he going to go put this up open source so you can go have a bill of material cut list from SendCutSend, and then he's going to give you a bill of material list from McMaster Car so you can go buy some bolts? I don't think so. So I wish. That'd be nice. Well, yeah, again, possible. Is there any way to get this out of here? Yeah, I mean, look, it's something, I want to build a wiki for all this. I want to have, I do plan on having a wiki for, let me get out of here. I do plan on having a wiki for STL files, step files, spec sheets, weights, and as many frame scans as I can do that I'm willing to give up, or at least give some ideas. That's what we're missing, is the adaptation of one place to go for that. John Angle with the Onyx motorbikes did something that was very good for that company, as people were like, hey, now that the company went out of business, everyone went there. So if you're not sure what it is, ONYX, Onyx Motorbikes, he has, throughout 5 years, just built his own wiki on one little electric motorcycle. There's a few little sporadic things here and there and here and there. As I gather more CAN bus data, 45 data on the Surons, the difference between the wire and harnesses of the 2018 to 2023, 23, 24, 25 different wire and harnesses of the Light B. I've built my own, like I use Miro here. This is my knowledge base. It's my visual memory knowledge base, which isn't loading now, probably because I'm just killing my memory. Oh yeah, my memory's just shot right now. So like, there's no wiring harness for the Hyper-B. So when I was doing a Hyper-B aftermarket kit, yeah, I'm shot on memory. I had to make my own schematic. So that is, well, this is embarrassing, Miro. Why are you so bad at this? See if I can retain some memory. But to have a place for all the wiring diagrams, schematics, blink codes, this and this and that and that. So I had to build this all out by hand. Every single one of these lines, what each one of these are. Background electrical engineering, this is like not hard for me. I didn't need to do this in an actual PCB design program. This was a project that ended up not working out so well for the Sauron Hyper-B. They ended up coming out with a 8 kilowatt version. So, but my Hyper-B now has a 12 kilowatt controller in it, which is great and fun. But yeah, that's just a lot of work. So you're asking like, why don't we? Why don't we? Well, the age-old question is, who was we? All right, I'm going to go offline unless you guys have got more questions. Happy to jump online for another one of these. We can kind of go free form. Next time I'll have a second monitor so I can see the chat. Apologies for that, so you don't have to see me staring at a screen within a screen within a screen within a screen within a screen. All right, to those just viewing in, what we really went over today was all the different geared motors available in the world, suitable for motocross off-road bikes, because that's what I like. Plenty of direct drive motors, plenty of hub motors. Maybe next time I can pull in some guests and they can talk about their hub motors. I didn't plan on talking about controllers here. Didn't plan on really talking about battery fitment and layout. We can definitely do that on another one. With so much vibe coding, there are some really good web-based CAD layout battery programs now, which are phenomenal. One is Battery B. I'll just give everyone a quick, fun, quick into that, a little tease. So let's open Designer. So oh, this one sucks. Let's find another one. I'm worried this is broken. It was broken for a while. All right, cool. This is my Hyper-B battery. Let's find, so I was able to, you can export your spacers for your battery, and see if I can go find my archive. Hyper-B battery. No, I don't do that. That was just a funny thing I wrote. This should be Hyper-B or one of the Hyper-B. This is the Hyper-B Fardriver. Here it is. All right, so like for example, should I open source this? Yeah, I mean, I can put it on 3D Colts and charge people $25 to download and print this. That's probably what I'll do. The Hyper-B display I made based on the ESP WaveSure display for the case for it. I should charge $5 for that. the wiring harness that I get made in China for $54 per. When ordering 50 of them, I should charge $130 for, because you know that's what you have to do. It's not giving stuff away. It's not how the world works. It's capitalism. So that's the battery case. That's Fardriver. So a lot of work goes into open sourcing stuff, and it's hard to just say like, yeah, sure, I'll do that. All right, this is Hyper-V. So these were the Hyper-V battery spacers right here. I printed these out with a little bit closer tolerance here with ASA, just because of such a tight space in the Hyper-V. Morgan didn't want to do this. I do have a different manufacturer willing to do this for me. Print out with closer spacing than the normal stuff they provide. As you see, that's a lot closer. That 0.5 millimeter on each of them did add up to where it wouldn't fit in between the cradle of the frame. But yeah, so this is battery B. They'll take care of everything, including the bus bars, if you do ask for them. Let's turn off the case. You have to lay out the series and stuff like that, and then the bus bars will form. So let me get out of my diatribe, because I don't think yeah, we could do a weekend community type of thing. You know, I'm on the we used to do a monthly meeting with Dust. It was an hour long, and this was with 150 people. About 30, 40 people would show up every month to their monthly meeting. This is the Dust Hightail, similar to the Bonnell 805. The great thing about that is, you know, it's just open, open, open. You can invite a few collaborators, share a screen. I'm okay with that. Do I want to drive that and take control? No. We can probably find a universal platform that'll let everyone do that and take turns sharing screen, probably just Zoom or something, and then we can collectively share products. And you know, a lot of people really suck at the part that you need to do on the project, which is pictures up close before you have it all done and muddy. We're always asking, how did you do that? How did you do that? Da, 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 da. So yeah. What motor I recommend? I mean, right now, if you don't mind the little extra weight, 3-shoal for sure. The 3-shoal, I went over at the beginning of this video. You're going to have to wait till the live is over and it's done rendering. The 3-shoal is this guy right here. For the simple reason of it is insanely, power to weight ratio is just amazing, and size. Like, you can't beat this size of the motor. Let's take you back to the Drew motors. Throttles. I love the Alta one. It's that German company. To be honest, I just use surround throttles pretty often because I'm with VESC, right? If I have a bad throttle mid-ride, it's not hard for me just to go in the phone app, set it to 180 phase amps, press forward, press hold after releasing, and it is ride home at 180 phase amps, like whoop-de-whoop, if I truly am stuck like that. Or I just have it in my hand, just forward, stop, forward, stop. So I can just get away with a $16 surround throttle. I had the first FX throttle from Matt Hoover of FX throttles, who I think is fine. It was just a really pretty looking single Honeywell Hall sensor in there. It's held in with hot glue. Like, it's just got hype. Who else? I think Grin Technologies, or one of these like e-bike companies, has a really good billet throttle. Who else? For regen, I like those really thin finger ones, the scooter throttles. I tried the Dial, DYOL. Hate that thing for off-road motorcycles. Just bounces all over the place. Still my favorite regen throttle is a boosted rev. If you ever get your hands on a boosted rev regen throttle, it is perfect. Absolutely, absolutely, absolutely perfect. All right. So yeah, the perfect motor is the one that fits in your project. And also one of the problems with these QS motors, the 138s, these ones ended up sticking out a lot. So you had issues with your rear brake pedal to get the chain to align perfectly down the center of your swing arm. So that was what was beautiful about using the 165 is you got, didn't stick out too much because remember your foot peg starts right here. I can't draw a rectangle in this area because it's not on a good plane. That's what's good about the 165. It has more power, doesn't stick out as much, and you have a huge open area down here for your brake lever to stick out, where the 138 didn't allow that as much. That's my experience. I still like running a rear brake lever down there. So best motor for the value. I mean, my goodness, you can get these things for $250, these guys right here, from China, plus a little bit of shipping. The standard V370H. This is the most popular. You're going to see 10 builds for every one of the other. All right, I'm gonna bounce. You guys have fun. Where's the rest of my stuff?